Hello everyone. In this video we will talk about Windows DLL hijacking. So, everyone who is working on Windows must be familiar with the term DLL, or what's DLL actually. Actually, DLL stands for Dynamic Link Libraries. Dynamic link libraries are libraries used for the functionality of the executables. Okay, so an executable in the Windows environment has DLLs to provide functionalities in order for this executable to work correctly. So whenever a program is launched, it has a set of DLLs to look for and execute. Okay. And these DLLs could be located anywhere in the file system in Windows. It could be in the directory of the program or the executable file, or it could be the Windows directory, it could be the path environment variable. Okay, so that's a short summary for DLLs. Now, in this tutorial, we're going to demonstrate how one can practically demonstrate remote access by exploiting DLL, let's say misconfiguration, or demonstrate DLL hijacking. Okay, so guys, DLL hijacking occurs when there is a DLL missing from the file missing from the file system. Okay, so when a program is launched, it's gonna look for the DLL specified in its source code, and if these DLLs are not found, okay, if these DLLs are not found in the directory from which the program is launched, okay, the system tries to locate. When the system tries to locate the DLL in other working directories, such as the current working directory, the path environment variable, the system directory, Windows System 32, whatever. Now, so we have two boxes over here. We have the victim system, okay, and we have the attacking box. So in this box over here, we're gonna make a payload or DLL payload to be placed on this system over here and execute meta preserved shell. But before going through that, we need first to identify what is the executable file that is missing the DLL. That's the first step. After we find the executable file that has missing DLL, we need to find what's the name of the DLL that the program or the file is looking for. So we can create a malicious payload that has the name of the missing DLL file and place that DLL or malicious DLL file in the working directory of the program or in one of the directories that I mentioned, path environment variable or the system directory. It all depends on the permissions of the current user. Okay. Now, if you run Task Manager over here and go to Services, sort that off. Okay. So here we have been told that debug service is a service that runs automatically whenever the system starts. Okay. And this service has an associated process, okay, that's also started when the debug service is started, okay. They start together automatically when the system reboots or restarts, okay. Now, we have been told that the process or the executable file of this service, okay, is missing some DLL called debug.dll, okay. Now, normally, you need to find the DLL yourself. Okay, so let me first find the process, the associated process with this debug service. If you click on go to process, we're going to see the intended file that we are looking for. So what we do is we grab our command line, and from here we launch a command called tasklist/m, which lists the current running services and the associated processes. Okay, so tasklist/m, and over here I look for the debug. Something has to do with debug. Let's see here. Okay, so I have developer service, but the system has not been able to identify the DLL. Okay, so normally so actually I made a mistake. So instead of saying the executable file and the associated DLL, I said the service and the executable file, which is actually the other way around. This command is for finding the executable file and the associated DLLs, but for some reason I cannot find the DLL associated with my targeted executable file, which is the developer service. Okay, now if we go back to Task Manager and go to Services, can open the full view. All right, so Developer Debug Service. So I click on Properties, and I see here the service that I have been told that has a process missing DLL. I can see that the path of the associated executable is C program files, developer debug tools, service, developer service.exe. Okay, now we need to find the DLL of this. But as I told you, the DLL or the missing DLL of this executable file is given, which is debug.dll. But I'm giving you the way, if for some reason you have not been given the name, you can find it using this command. For some reason, I can't see the DLL here. The other way is using process monitor to find the current or the DLLs that the file is looking for. Okay. Now, process monitor, everyone should be familiar with this tool, but I cannot download it to this machine since this machine doesn't have internet access. Okay. So all what we said is only explanation for your understanding. Okay, so we have been given the name of the DLL. Now the next step is going to our Kali machine, and now we are given the fact that we have a client machine or a client machine or endpoint that have or that has, let's say, an executable file or a binary file or let's say a program that's missing a DLL file. In order to test if this program or this executable is coded securely, we do what's called DLL hijacking. Okay, so in real world, when we have a project, okay, and we have a team of developers working on a program, working on developing some program for some enterprise or for some functionality or for some purpose. Now this program will have source code, okay, and this code will be compiled in the final stage to produce a binary program, executable program, whatever, okay. Now, this executable program needs to be reviewed, or what's called in the security community, code review. Okay. Now, during the code review, the developer or the team of developers should take care of all the DLL files and make sure that all of the invoked DLL files have, I mean, um, all of the DLL files should have all of their paths mentioned. Okay, it needs to be. It doesn't need to be. I mean, implicit path. It needs to have the full path specified and explicit. Okay, if the path of the DLL is not specified explicitly in the source code, okay, the program will have difficulties finding the DLL. Okay, so you need to make sure, in order to prevent DLL hijacking, you need to make sure that all of the programs, all of the source codes you have, review the source code, try to find and make sure that all the DLLs, okay, have their paths specified and explicit, or at least put the DLLs or the needed DLLs in the directory from which the program is launched. That's how to prevent or to secure against DLL hijacking. So let's say that we need to test a client endpoint, okay, for let's say they have, as we can see, as we said, they have developer servers program, okay. So we need to test if this program or this binary program is secure enough to prevent any kind of let's say malicious code execution or remote code execution against this program. You need to make sure that the program is secure enough, it's coded securely. So one of the ways we try DLL hijacking, okay. So let's go here to our box, launch the terminal, and from here we make directory desktop called DLL. Okay, now we see to that. Okay, now what I'm gonna do is generate DLL payload using Immersive Venom. Then setting up listener in my Kali box, transferring the DLL or the malicious DLL to the client machine or the endpoint machine to test their developer service executable file if it's well coded securely or not. Now, what we're going to do is use MSF Venom -p Windows payload interpreter. Yeah. Reverse TCP. Now we need to specify the L host. It's going to be our L host is, I think we need to find the IP address. Okay. So it is, no, I don't like copy paste. Okay. And let's say L port is 4545. And then we specify the extension of the file, which can be DLL. And we say, here you need to make sure that the malicious DLL file, okay, needs to have the name, okay, of the missing DLL file that you learned about, which is going to be debug.dll. Now in another terminal, let's set up MSF console. Seeing that we have our payload generated, okay, let's start Python on the port. Okay, and let's start here our listener. Failed to load module. Okay, now we set the payload lhost which is then set port 4545. Yep. Okay. Now we run this, and we have our listeners set up to capture connections. Now we need to go back to the endpoint. From here, we download the malicious file by browsing oh, I like this. Okay. Is the IP address correct? Then oh, I forgot the port. Okay, now that's our malicious DLL. We download that. And initially, we're going to save that to desktop. Okay. Now the next step is, now I have the missing DLL, which can test if the program has been coded by my developer team was secure enough to look for a DLL which has explicit file path or not. So we're gonna look for now a directory which the current user of the system has write access to. Now, initially, we're not gonna place this file in the directory of the program. Okay. Now the directory of the program is program files. Nope. Program files. Yeah. Okay. Service, developer service. Now that's the executable file that you are testing against DLL hijacking. Now, if this executable file has been coded securely, it's gonna have two scenarios to run all the associated DLLs. First, which is the most secure option, is to have all of the DLLs under paths specified explicitly in the source code. The second way is to have the DLL in the directory of the program or the executable file. That's the two. Actually, it's not the two. Let's say first, as I said, that's the second way of securing your binary or executable file against DLL hijacking. Okay. Now, if you don't have all of your DLLs specified in the aforementioned ways, you are making your program exposed to DLL hijacking, because the next step, the system will try to find this missing DLL. Okay. And I can now have my malicious DLL file placed in some directories that the current user has write access to, and have the system run my DLL, okay, which is missed on the client's side. Now, apparently, the current user doesn't have access to Windows, write access to Windows. You can see that, simply by clicking on properties, security. The current user doesn't have write access, so I cannot place that here, neither in Windows System 32. Now, I have two ways, okay? I can try to place this file in the temporary directory, which is not going to work. The place that we need to find or to place the DLL file in is the path, okay? Now, how you can display the path variable using CMD, and from there you see here echo path. Now I displayed all of the directories that are under path environment variable. Now the current user has access or write access to all of these directories. I mean, most of them, if not all. Now, as I said to you guys, the system, if it doesn't find it, the DLL and the aforementioned directory is going to try to look for them in the path environment variables, or path environment variable, sorry. So one way we can hijack this is by copying that and placing this in the first environment variable. So when we launch the executable file that we are testing against, if it doesn't find the DLL, it's going to look, the system will look for the DLL file here in these directories. It's going to look them by order. And since I have my malicious DLL, in the first path or the first directory, it's going to run my malicious DLL. That's how DLL hijacking occurs. So let's copy that. Let's go to that directory, program files, x86, common files. I guess I'm an Oracle, Java path. Refresh, and now I should have a MetaPredator session captured in my Kali box. Let's examine that. Let me try execute the file first. Okay. I think I need to restart the machine or restart or log out and then log in to have the service rerun again. So let's do restart. Oh, okay. So as you can see here, I have MetaPredator session established. Okay, I can browse the file system, explore all ways to, let's say, let exfiltrate, go around the system, find whatever I'm looking for. So here, let's type help. We can do hash dump. We have many things to play around with actually, since once we have the MetaPredator session established. So guys, that's it. Okay. I hope that you learned how to do DLL hijacking, how to test your executable file against DLL hijacking. And as I told you guys, the most secure way to prevent these kind of attacks is to have all of your DLLs and your paths specified explicitly in the source code, or place them in a directory from which you launch the executable file. Don't let the system look for the DLL, because if it doesn't find, you raise the probability of your system being hacked. Okay. Oh, so I am logged in again. Yeah. Okay, guys, that's it. Thank you so much.